I am Kayo Matsushita from the Center for the Advancement of Higher Education and Research, and so I would like to talk about pedagogy for active and deep learning. So the theme for today's symposium is deepening active learning with peer instruction. So I want to explain why we have added the phrase deepening. So that is what I would like to focus on. So the focus is on the word deep. So Dr. Mazzulli said that it's not the technology but the pedagogy that's important. And so I used the word pedagogy here in my title. And the contents I would like to make is very simple. So in university education, the Ministry of Education is strongly proposing active learning. So it's like a trend. But I have a question. Is active learning enough? Is it just sufficient for the learning to be active? So I want to emphasize deep active learning. So there also needs to be the deep aspect. Then one method of making it happen is the peer instruction. So that would be the focus of my talk today. So now, what are the issues related to active learning? What are the challenges we're facing in a Japanese university in conducting active learning? So Wiggins and Maktai, well, Dr. Nishioka of Kyoto University has recently come up with a translation of their paper. And so in the traditional curriculum design, they said that there were twin sins of the traditional design. One is that there was too much focus on the activity, meaning it's hands-on without being minds-on. So Wiggins et al. Said it's hands-on without being minds-on, and Dr. Mazur said a while ago, and so it has to be brains-on. So this issue especially is seen at the elementary level, is what they say. So I arrived at the center in 2002, and before that, my focus or specialty was on elementary and secondary education. So I really agree to this first point. And another issue, another sin, is coverage. Too much focus on the coverage in the teaching. Dr. Mazur said in his talk, he mentioned that, well, about the teaching according to the textbook or lecture notes. And so some instructors will try to cover all what's said in the textbook or lecture notes. And this is mainly seen at secondary and higher level, is what Wiggins and Maktai are saying. So there are these twin sins. And with that in mind, if we look at the current Japanese university education, I think there are such twin sins, and in the background, there is the shift from teaching to learning. Needless to say, but there's a shift from teaching to learning. And under this condition, well, there's a criticism on the too much focus on the coverage in like the first year or second year. At the lower grades, our focus is being from lecture to active learning system, and so we are seeing more active learning style classes being held. But we should not forget the first sin as well. So in the current active learning, there's a tendency that we put too much focus on the activity is the issue that I would like to raise. So when we say active learning, I think that we have to make a distinction between internal factor and external factor. And for external factors, suppose that we have to see how active or passive we are in external factor and also in the internal factor. So there are these four quadrants as you see here. So for example, Dr. Mizukami said that, well, the students seem to be so excited, but in the mini essay, he feels that the quality is lower in the class, and that's because it's hands-on without being minds-on is in this right bottom quadrant, C. On the other hand, like I have a license teaching English, and when I was in university, there was a class at the School of Literature that I took explaining Shakespeare, and I really remember this class. And the professor was just reading out the lecture notes, and I was just taking notes. But I think my brain was really activated. So it may seem very passive, but my brain was very activated. I think there would be such a case, and that would be fit in the B quadrant. But of course, the ideal state would be A, meaning that there should be high external factor as well as high internal factor. So A is probably the ideal state. However, the current active learning, I think, has A and the C is not differentiated enough, is what I think. That's the challenge, I think. So we need to overcome these challenges, and to do so, I want to propose deep active learning. And our center in 2009 and 2011, we had programs, and this year, 2002, we're having the symposium today. So we had these themes, relevant themes. And in 2009, we invited Dr. Carl Willman, and the topic was Future of Science Education at Undergraduate Level. And in last year, Dr. Ferenc Martin, he's a proponent of deep learning. So symposium was toward university education based on deep learning, and this year we are having the symposium with the title Deepening Active Learning with Peer Instruction. So this is the summary of what I just said. For example, Dr. Carl Wayman has published on the journal Science about the effects of active learning, and so he learned Dr. Mazur's peer instruction, where he wanted to come up with a new learning style for physics. And Dr. Ferenc Martin from mid-70s has established the concept of deep versus surface approach to learning. And this year, we are very delighted and honored to invite Dr. Mazur, who is the origin of all these concepts. And so looking back, we recognize that learning must be both active and deep. And I tentatively call this deep active learning. And so last year at the panel discussion, Dr. Mizokami prepared this slide. And so active learning on the left side is focusing on the activity or methodology, whereas deep learning on the right side is more focused on the contents. So this middle portion, where the two circles meet, needs to be emphasized, is the proposal made by Dr. Mizokami last year. Now, when we say active learning or deep learning, well, needless to confirm the definition, there's a simple definition listed here. Active learning is an umbrella term that refers to several models of instruction and learning that focus the responsibility of learning on students. It says learning, but it also includes the model of instruction as well. And whereas deep learning has to be based on the understanding of concepts, and it should enable wide application of these concepts and possibly lead to lasting changes in thought, feelings, and behaviors by practicing certain learning approaches or models. For deep learning, some of the audience here may have heard this word for the first time, but there are at least two schools in this deep learning. One is what I just introduced. So Martin et al. Is proposing this deep approach. So for the students, so we have to be able to compare the deep approach versus surface approach to the students. Like the surface approach is more in obtaining the credits, whereas the deep approach is to understand the ideas. And we'll not go into details, but there's the comparison between deep and the surface approach. So that's one school of thought for the deep learning. And another is the deep understanding is the title of Dr. Mazur's talk today. So understanding by design. Biggins and Maktai has come up with this idea that the class has to be designed to promote understanding. So there has to be at least 3 levels of the structure of knowledge is what they're proposing. So for deep understanding to take place, there has to be a big idea and core tasks that needs to be identified. And on top of that, it has to be linked with a more practical aspect like the skill. So these are some prior research that should be helpful. Now, going on to methods of deep active learning. Well, there are many possible methods, diversified methods, like the peer instruction. It can be applied to many disciplines. And although more limited, there's the problem-based learning. Well, for medicine or in law, it's this PBL approach is taken. And in Niigata University, we're doing joint research with the Faculty of Dentistry. And at Niigata University, they have this scenario where the teeth is growing sideways, and so they're picking up some practical clinical cases to prepare a teaching resource, and so the group of students will get together to come up with a solution. So what students will set up a learning task of what they lack to solve this task, and then individual learning takes place, and 1 week later the group will get together to share the learning results, and so as to draw a conclusion by the group for the initial task. So it's the combination of the group learning with individual learning, and also combination of in-class and out-of-class learning. So for deep active learning, there are various methods or structure, but I think one common structure is what I outlined here. One is that, so as in the previous example, there are solutions that cannot be reached in the current knowledge, and so to work on that task, so there will be a cognitive conflict involved. So, and the students will have different way of thinking. So as Dr. Mizokami said, he talked about being more social, or students being more social. So the students are encouraged to have a discussion with the presence of the conflict, and there will be support by the faculty so that they can shift from having preconception or misconception to reaching to scientific concept. And I think this is a common approach for the deep active learning. So as for the procedure of peer instruction, Professor Mazur has given us full explanations. I would like to skip this page. And now, for peer instruction, I first learned about it by Carl Iman's, by listening to Carl Iman. At that time, what I felt was, well, isn't this what we call lesson based on hypothesis experiment in Japan, is what I thought. Well, I used to be specializing elementary and secondary education. So from student days, I am more familiar with the lesson based on hypothesis experiment. I think many of you are familiar because this was developed by Dr. Kiyonobu Takakura back in 1963. And mainly, at the primary, this is mainly used in the primary and the secondary level, but it's also used at the university. Like in Kyoto University, at the introduction to physics at our university, this kind of lesson is conducted by Dr. Funahashi. So this is dropping the golf ball and ping pong ball to ask this. It's a physical experiment to see which ball falls faster. So if it's dropped in the lower distance, if they fall in the same speed. But what about if they're dropped from a high speed? So maybe addition can be made. But the Kyoto University students think about the ideal situation. They're used to that. So they would say both balls will fall at the same speed is the tendency. And the ratio, Dr. Funahashi says that the Kyoto University students have the highest percentage that both balls drop at the same speed, and so that's kind of wrong. But so they they would come to recognize such misconception. So this kind of lesson is to encourage the understanding of basic scientific concepts and principles by repeating the cycle of problem, prediction, discussion, modification of prediction, and experiment. Now, this is the comparison of pure instruction and lesson based on hypothesis experiment. So, hypothesis experiment lesson is designed for a single class, so about 30 to 40 students, whereas for the pure instruction can take place in a very large classroom setting. And in case of PI, pre-class reading is necessary, and based on that, concept test is given, and the first answer will be voted, followed by discussion, followed by the second voting. And according to the ratio of the correct answer, sometimes the discussion point part can be skipped. So that's how the PI is designed. And the hypothesis experiment lesson is almost at the same design as PI, but there's some difference. So for the pure instruction, these are some questions I have for pure questions. So if we compare the two lessons, well, the similarity is that both system is designed so as to enable any teacher to achieve a teaching success. In case of hypothesis experiment, it could be used by the mothers who are taking care of their children, and also another similarity is that it's a multiple choice question revealing students' misconception. And number 3 is that both would have discussion with peers, and based on the multiple choice question, the students can self-assess their conceptual understanding. And also, we saw that the peer instruction or this has both the individual thinking and collective thinking time. So both individual and collective activities involved. And on the other hand, there are some differences between PI and hypothesis experiment lesson as well. Some are not so important, but in the university, the PI can be used in large size lecture and also use of clickers. But Dr. Matsura said you don't necessarily have to use the clickers. And today, we did not hear too much about this, but there was a mentioning of 35 to 70% will be the basis of the understanding where the discussion will take place. That's the condition. So in case of pure instruction, such just-in-time teaching can be conducted. And the greatest difference is that so the focus is not on experiment by explanation, but Dr. Matsura, according to him, there is some experiment being done for PI, but for hypothesis experiment lesson, there always has to be experiment. So in the case of PI, it has higher applicability because PI does not necessarily require the experiment. This is one thing I can say. Now, these are some questions about peer instruction. There are two. One is, well, listening to Dr. Mizokami's presentation, I felt that designing of the concept test can be quite difficult and challenging. So Dr. Matsura's, we had a interesting workshop, and I felt that, well, if there was a certain percentage of students who give a correct answer, but some percentage of students who answer wrongly, so we have to come up with a question to come up with this just about the right percentage of students who give correct answer. And also, in case where the misconception is very clear, it may be easy to design a concept test. But in case of social science or like in humanities, it can be quite challenging because misconception is not so clear. So how can we construct or design a concept test is the difficult. And second point is the effectiveness of discussion. Well, actually, in the previous question, so Dr. Iguchi and Dr. Taguchi, we were having a discussion a while ago in the workshop, and we selected different answer, 1, 2, and 3. And after discussion, even after discussion, 3 of us did not change our answer in the second vote either. So meaning that so sometimes discussion may not be effective depending on the students. So rather than the discussion, maybe, well, in the discussion, well, of course we can enhance the engagement of the students. So that will set the stage for the students to absorb the explanation by the instructors, what I think. So maybe there may be a limit as to how much a student can learn from the discussion. Of course, it would be a nice, it would set a nice setting to absorb teacher's explanation. And I selected number 2, and Dr. Iguchi selected number 2 and number 1. And he said, and Dr. Iguchi tried to convince me with this warming of the glass, as Dr. Mazur explained, but I tried to rebuke him. But Dr. Mazur used the metaphor of us holding hands. And listening to that explanation of the holding hands, I really was convinced, meaning that, well, the explanation or the has to be really fitting to the misconception of the individual, then the student can learn. If the explanation or the convincing of the peer is not really pinpoint or fitting to clear the misconception of the student, maybe the discussion will be not so effective is the question that I have. So I would like to ask Dr. Mazur about the effectiveness of discussion later on to please answer to that. So that's all from my side.